Hi, everyone. So like Shane said, I'm a grad student here, and I've got my MATLAB t-shirt because I really love MATLAB, and I'm excited to talk to everyone about it today. Okay. All right, so the first thing that I need to do is to thank Oppo. He gave this talk for a very long time, and a majority of these slides are from him, which I've just sort of adapted with examples of things that I do in MATLAB. So first, I want to thank him. So I'll start with some background on MATLAB and some getting started. So if you haven't seen MATLAB before, this is the part of the talk where I'll really just get people oriented, show you how it all works, and then talk a little bit about how to write scripts, how to write functions, and how to use the editor in MATLAB. Then I'll give some quick examples of different visualization tools that you can use in MATLAB, miscellaneous advanced topics, but these are certainly not representative of everything you can do in MATLAB. There are lots of things you can do. And then I'll talk about specific things that are good to know about MATLAB if you're doing it here at the Martinos Center. Okay, so to start with some background. So what is MATLAB? The name for it actually comes from matrix laboratory. And that's because the basic data structure in MATLAB is matrices. So if it's a 1D matrix, it's like a vector, 2D matrix, 3D. And this data structure actually works very well if you're working with imaging data. It's a scripting language. You can use it for scientific computation, visualization, and this is Appo's slide. He said, "You're best friend," and I agree that, you know, it's one of my best friends too. So MATLAB's pretty great. And what can you do? You can do lots of different data processing. There's also a large majority of toolboxes that are built into MATLAB that MathWorks, the company that runs MATLAB, has written themselves. But there's also a lot of other toolboxes that other research groups have used. So if they have written something in MATLAB, you can run that on your own MATLAB here at the Martinos Center. And the reverse is possible. You can write your own data analysis scripts and then share them with other people as well. And so with anything, MATLAB has its pros and its cons, and there's double-edged sword to each of those. So two of the pros of MATLAB is that it's a commercial package. So support is available. You can email. Everything should work. One thing I really like about MATLAB is that it has really great documentation. There are people whose job it is to write scripts or to write websites to show you how to use all of their information. And it's also great because it's a scripting language and you don't need to compile. So if you're doing something in like C++ or other languages, you first need to write your script, compile, and then run it afterwards. You don't need to do anything like that in MATLAB. And you can do really easy online debugging. I'm going to do a demo of the debugger a little bit later on, and it's one of my favorite things about using MATLAB. But there are also cons to both of these pros. So for a commercial package, you have to pay for it. And at the Martinos, this is something that we don't have to worry about because we have a lot of the toolboxes installed. But if you were doing this as a non-academic, they can be very expensive. And you might not have research packages implemented as quickly as opposed to, say, Python. So a lot of the stuff that's been going on in machine learning recently, a lot of people are just using different things written in Python because they wrote them quickly, put them up. But I'll be getting to how you can interface with Python later on. And then the downsides of the scripting language is that you don't have explicit types. So MATLAB will sort of try and guess what you mean. And I can give some more examples of that to come. And so I already quickly mentioned MATLAB, but so if you wanted to use the free version of MATLAB, there's something called Octave. It's similar to MATLAB, it just might not have the latest and greatest in terms of toolboxes and support. Scilab is another option. And then Python is something that a lot of people are starting to use now, which is a free generic scripting language. There's lots of toolboxes available. Personally, I use Python specifically for some different machine learning things, but primarily use MATLAB. If you're trying to decide which of the two languages to learn, it sort of depends on what packages you think you'll be using, who you'll be collaborating with. If you're joining a lab that uses one or the other, that's a good way to decide which is best, but I personally like both of them. And once you get good at one, you're just a little bit faster in it. And a lot of the things that Python uses, actually, like the matplotlib, that's the MATLAB plotting library. It'll use things within MATLAB. And you really should just learn whatever works for you, and that makes your workflow efficient. And if you're getting started with programming in Python or MATLAB, whatever you learn in one of those languages will translate to the other in terms of just learning general programming best practices. Okay, and so getting started. To open MATLAB, so if you are on a Linux box at the Martinos Center, you can just run the command MATLAB or MATLAB ampersands if you want to run in the background, and that will be the default version of MATLAB at the center. This is something that I think the help desk sets. And so whatever the default version is, if you're in MATLAB, that's what will open, but that's not necessarily the latest. So say you wanted to use version 2016A, and sometimes you want to use a specific version if you know that your code runs in that, and then there was some update. Then you can just go to this path, user, public software common MATLAB, and then R, you can do 2016A, 2017B, and then bin MATLAB, and that'll do basically the same thing, but for the specific one that you need. Okay, and so now, yes?
And you can always find the most recent version as matlab.new.
Yes.
That's always the most recent version of MATLAB.
Yep, matlab.new. Okay. All right, so now a little bit about what is MATLAB that I've just sort of been doing some slides on. All right, so this is MATLAB. I have to close the show for now. All right, so here's the MATLAB IDE, or Integrated Development Environment. So certain programming languages, you'll write your script in like a text editor and then run it on the commands line, or you can have something that both is a text code editor and it runs the code as well, and that's the category that MATLAB goes in. I mean, you could in theory write MATLAB code in a text editor and then run the script, but I wouldn't recommend it because I think the MATLAB editor is very helpful and useful. And so on the left, this shows your file directory. So where are you right now? What functions are on your current path? So wherever you are, you can run any of these scripts from here. And then if you have a .mat file, it doesn't look like I have one here, but the information will show up here in the bottom left. And then in the center, this is the default orientation. The editor is right here. So this is where you can write MATLAB code. If you want, you can undock this. This is what I normally do when I'm writing, but I know some people like to have it docked. So you can take it out, move around, split windows. I'll dock it again for now. And then here is the command window where you actually will run MATLAB code, and on the right is your workspace. And once we have some variables, that's what will be there. And so the first thing that you generally do with any programming language is you display the phrase hello world. So the way you do that in MATLAB is you use disp, which is short for display. And then to make a string, you use single quotations. And you can type in hello world or hello world, whatever that was, okay? And there it is. And then you can also do other things on the command window. You can create a variable A that's equal to 2. And now that's going to show up in your workspace. Maybe you can have a variable B that's equal to A times 2. And so you can run those commands right there. Okay? And so now I'm going to go back to my slides. So oftentimes when you're running any code, the first thing that's going to happen is you may have some challenges you might need to debug. And because MATLAB is your friend, it wants to help you. And so there are lots of different ways that you can debug your code. So the documentation texts are informative, as I mentioned before. And you can also use the command help. So if you just type help and then the name of another command, it will display the information about that function. And then if you type help desk or doc on the command line, then an interactive help system will be launched. Then you can look for things there. However, I personally prefer to just go to mathworks.com, where you can just Google like MATLAB transpose vector, and it will give you all the documentation you need online with links to lots of other examples and similar functions. And then there's also something called MATLAB Central, which is where you can find code examples or functions written by people in the MATLAB community. So it's not something that is technically a product of MathWorks. They might not be able to help you debug it, but I personally have found lots of helpful scripts there, which you can download for free and then put into your own code. Okay. And so now I'm going to get into some basics of the syntax, ways that MATLAB is maybe different from other programming languages you've seen. So to create a vector, all you need to use is the colon operator, where the first element is where you want to start, and then you put in the step size. And if you don't put anything for the step size, it will just default to 1. And then another colon, and then that will go this is where you want your vector to end. So here, x would be basically 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 is a vector. If you want a row vector with specific values in it, you can also just put them, you can write them out explicitly. And for a row vector, it will be commas. For a column vector, it will be semicolons. And at the end of all of these lines, you'll notice that there are semicolons. In certain languages, you need to have a semicolon for your code to run. In MATLAB, you don't need it, but it will suppress the output to the commands line. So if you say run my script and you have 100 lines of code and none of them have semicolons, it's going to print all of that. And if you have a fMRI volume that's really big and then you don't have a semicolon, it's just going to print to the command line the values of every single pixel and voxel over your whole time sequence. And that can actually slow down your code running in addition to having things pop up that you don't really care about. So semicolons are very helpful. So now some ubiquitous MATLAB commands that if you're writing any script you'll probably need. So size will tell you the size of a variable. So if the first thing you do is load some imaging data and you want to know how many time points do I have, you can say size of my data, and then it will output the size of the images and how many frames you have, depending on how the indexing is set up. But you can also use this for even just smaller things that you're creating in MATLAB. It doesn't have to be a big variable. And then zeros. This is what is used to allocate memory. So if you know that you're going to have this big matrix that you're slowly going to populate throughout your script, it's good to allocate that memory ahead of time, and then when you do your computations, you can tell it exactly where to go. And this is something that in other languages you would need to do explicitly, and in MATLAB you don't have to, but it will oftentimes give you a warning that if you don't allocate the memory, it will say, oh, try and speed up your code by allocating ahead of time. And so these are all of the nice little math operators, and by using the dot in front of it, you do it element-wise. So x times y, because this is a matrix laboratory, if you didn't have the dot here, it would do a matrix multiplication by y. But if you just have a matrix x and y of the same size and want to multiply individual elements together, you can use the dot operator. And the same thing goes for division. And then repmat, this is short for replicate matrices. So if you have these replicates of an array, here's just a code snippet. If you have the vector x, 1, 2, what you want to replicate is the first input to repmat. The second is the number of rows you want it to be replicated. And the third input is the number of columns. So if you have repmat x 1, 3, you have 1, 2, and then 1, 2 for a second time, 1, 2 for a third time. If you switch their order, instead now your vector 1, 2 will have 3 rows. Okay, so I kind of just breeze through some things quickly. I have a couple just quiz questions you can answer out loud or just in your head if you'd like. So if you put this into the MATLAB command line, you first created a matrix and then you're asking what size it is, what would be the output of this function? Does anyone want to guess? D? D is correct, well done. MATLAB expert. Okay, and so if you want to produce the vector 1, 2, 4, 16, which of these 3 inputs will do that? So, does anyone want to guess? Yes, exactly, so that's big. Okay, so now that I've kind of gone through some basics and we've done a couple of questions, I'll get a little bit more into scripts and functions and using the MATLAB editor. Okay, so typing commands into the prompt, as I did before when I wrote hello world and I did the addition, isn't going to be convenient in the long run. And it's better to write a script that can do all of your commands at once in the order you'd like them to. So when you're writing a function, this is the syntax that you'll be using. So in MATLAB, you start with the word function, which will automatically become blue because this is like a special word in MATLAB. So you don't want to create a variable or something that's called MATLAB, that's called function. MATLAB will probably yell at you if you try and do that. And then the next thing that you do is you put in your output arguments in brackets. The input arguments are in parentheses. This here, compute square, would be the name of the function. the file ends with end, and then everything in here is what actually happens in the function. So if you input args, say 1, 2, 3, 4, and then do dot squared, the output would be 1, 2, 4, 16, sort of like I talked about in the quiz example before. And you want to save your functions as a .m file. If you are running MATLAB on the cluster and you forget to add the .m extension, it will actually sometimes just save it as a text file. So it's good to include .m when you're doing that. And make sure that whatever you name your function is also what you write. Whatever you name the function here should also be the file name. And another important tip is that you don't want to overwrite a built-in MATLAB function. So earlier, I tried to create a function called plot in MATLAB that added 2 numbers together. And then when I wrote that function and tried to save it, MATLAB said to me, warning, function plot has the same name as a MATLAB built-in. We suggest you rename the function to avoid a potential name conflict. So just look out for those sorts of error messages when you're writing your own code. Okay, now I'm going to do an yes.
So what will happen if you actually do that?
It will run what you wrote. So if you say plot 1 to 10, it will try and do what you told it to do. It might change depending on what path you're in and what, if the function that you wrote is in the path where you're running your script. Yeah. Okay, and so now, this is a short example of a function. All right, so what you could do is say we have some script where we want to plot a parabola. Our input is going to be 1 to 50 with a step size of 2. And then it'll calculate the indices and then plot. So to actually run this in MATLAB, you can either write the name of this script. Here it's called plot x squared. Oops. And then it runs this code. Similar to the command line in Linux or something, you can also just do up arrow to see all of your previous commands. And so if we want to run it again, there's our plot. But instead of doing the code just in the script, you also can use a function. So the compute square example that I showed before, here it is as an actual function. If you ever want to see what's inside a function in MATLAB, you can always just right click and then open compute square, and that will show you exactly what the function is doing. And this also includes some MATLAB built-in functions. So even if you read the documentation and you're not sure exactly what's going on, you can look at what's inside functions by that little trick of just opening it up. And so here, instead of doing it by hand, we're inputting x. This is sort of a trivial example, so it would have been easy to keep it as 1 line of code, but oftentimes in your functions, they're much longer. So I'll run it, and then we get the same output. But basically, by using the editor in this way and running your scripts and creating functions, it's more efficient. Another thing that I want to highlight in this script is I actually keep most of my functions in subdirectories. So if you look over here, I have something called why and how functions, and inside it there is compute square and another one called compute square 2. If these were not on my MATLAB path, I wouldn't be able to run this. So I can actually do that now, remove from path. And then if I run this, or it didn't actually remove, you can tell because it didn't go later. Lighter, sorry. All right. Oh, does anyone know what I'm doing wrong? Or why this doesn't work? Yeah. I didn't actually comment out this line. So what my code was doing is I was manually removing it, but then my code was adding it using the add path command, so then it was working. But now if I run it, I can't run compute square because I don't have that function. Whereas if I add the command for add path, now I'm able to do it. And when you're writing more complicated projects and data analysis, having things in separate folders is a way to organize all of your code, but you just need to remember to add paths. Okay. Any questions so far? I'm sort of going through things quickly because I don't know how much of MATLAB things people have seen, and there's more interesting stuff at the end. Any questions? Okay, I'll just keep going. All right, so now these are just a couple more notes. You also, instead of hitting the run command, you can also just highlight it and press F9. You can also use interactive debugging, and this will give you different warnings and programming tips. So see the debugger, I have another script. Sorry, I probably just could have done these back to back. Okay. So also I'm going to clear my workspace. You can just use the command clear, and then that'll get rid of everything in your workspace. And CLC will clear command lines. So those are helpful scripts when you're running different things in MATLAB. So what I've written here is some code. Well, first I just have this thing at the beginning as an example. If you ever want to fold your code, such as this line here, you can just put it in an if statement or a for loop, and it can close itself up. But so below I have some more interesting code where I want to create a vector, and inside it I want to have the squares of the numbers 1 to 10. And so I run this script. The output, what I've computed, is the number 103. But what I originally wanted was a vector that's of length 10 that contains the squares of all of them. And so let's say I don't know why this isn't working. What I can do is I can set a breakpoint. So you just tap on the different lines on the side, and by putting this red dot, the code is going to stop there. And so I'll clear the workspace again. And so now that I've paused it, you can see that vector, I initialized it using the 0 function that I talked about before, is just 10 zeros. I'm like, okay, great, that's what I want. And I want to go through one by one and put the squares in. And so my loop variable is 1. So if I step in, now x1 is the loop variable. And then I want to square it and add 3. Okay, so I can look over here on the right and I see this is the right variable for x1, and then x2 is exactly what I want it to be, itself squared plus 3. And then I want to put it in the first element of my code. And the way that I'm going through line by line is using this step function up here. And so then I step, and then I can even put my cursor over the vector, and then I see, oh, all of a sudden vector is a double. It's just a single element. It's no longer a 10 by 1 vector. And so at this point, I can stop and say, oh, I see what I did wrong. I forgot to put my looping variable in here. And so now to remove a breakpoint, you can just unclick. And so now if I run it, you can see the output is what I wanted. It was the number squared plus 3. And another thing you can do in the debugger, which you may or may not have done before, is you can create a breakpoint and then right click. And you can modify the conditions. So say I'm only getting an error for 4. I can say if loop var is equal to 4, what will happen is it will run through the loop, and it won't start until the loop, or it won't stop until the loop variable is equal to 4. So if you see here, loop variable is 4, so we've already done the first 3. We have 4, 7, 12, and then a bunch of zeros. And then I can sort of debug at this point in the code. So that's sort of a good way to do debugging and figure out where certain things inside your code are breaking down. Okay.
Question.
Yes.
Can you add a debugging point to your functions?
Yes, you can. So you can also add breakpoints within functions to see what's going on inside of those. And sometimes you'll actually leave a breakpoint in them and then run it again. And then it'll stop in the middle and you'll be wondering why, and you can just take it out and let the code continue running. Yes?
What should I do with my method?
It skips breakpoints. So it, in theory, shouldn't be skipping breakpoints. I've had the experience before where I think I'm calling one function, and I'm actually, so I have like function version 1 and then function version 2. And in version 2, which is the latest and greatest, I put a breakpoint, but somewhere else in my code, I forgot to say, okay, now I want version 2 instead of version 1. So that could be a common mistake that I make, but it could be something else. But in theory, MATLAB should stop at every breakpoint. Or if you have a conditional statement, you could check the logic inside the conditional statement. So those are just sort of my first 2 thoughts. Yeah. All right, so now I'm going to get back to the slides. All right, so these are some more advanced uses of the MATLAB editor. So normally you'll run a script all at once, but you can also do things in cell mode. And so %sign is what we use for commenting in MATLAB. So if you have a %sign anywhere in the code, none of the code after that will be evaluated. And if you do two next to each other followed by a space, that will create a new cell. And it's basically a chunk of code. And it's also nice when you're editing because it'll sort of like highlight all of that code in yellow. And you can evaluate just a single cell by putting your cursor there, say evaluate cell, and then it'll run a cell or stop by turning cell mode on and off in the editor top panel. And so this is some example from Oppo, where you can see by having these two percentage signs here, which are highlighted in the screenshot, which is why they're black, you can run just the code in this section, and you don't need to run the things before or after, and then the next section is delineated by 2 more % signs. Code folding, I showed you that earlier in the demo. I didn't want to toggle back and forth again, but it's basically where you can just fold code by using if statements. And so if you put them into these blocks, it just makes it easier to read or to hide different pieces of the script. If you know one part of the script works really well and you don't want to spend time looking at it or scrolling through it, you can just go to other areas. Okay, and so one of the things that MATLAB is great at is visualization. And since this is an imaging center, in this next part, I'm basically just going to show you some different MATLAB commands you can use to display different things. But there are probably a million more things you can do, and if you just look up in the MATLAB documentation, there's probably something for whatever you can imagine. So plot 3 allows you to plot points in 3-dimensional space. And so this code here in the picture is an example of someone in my group who wanted to build a coil, and it had this specific geometry, and then this is how she plotted it by using the plot 3D. You can also look at 2D and 3D vector fields. So if you're looking at the magnetic field across a certain area and you want to see what direction it is and how strong it is, the magnitudes of these arrows can be changed as well as their direction using Quiver or Quiver 3. But if you'd rather sort of connect these, so you can see the streamlines. If you think of sort of magnetic fields from like high school with a magnet, you see those streamlines connecting from the North Pole to the South Pole. You could create an image like that using a streamline plot. And then there's also just very simple things you can do, like reading in a JPEG image using the imread command, and then plot it using image SC. Image SC is a really helpful tool. It's short for image scale. So it will automatically plot your image from 0, or so from the minimum of your image to the maximum. If you have data that ranges from 0 to 100, but you plot it with, say, imshow, you would only see differences between 0 and 1 because certain functions automatically plot between 0 and 1. So image SC is a good go-to for plotting. Also, when you plot things, there'll often be a default color map. So say you have a random matrix, 256 by 256 points, and then you plot it. This is what it'll look like at first. But then if you want to use the hot color map instead of the jet color map, you can change it using the color map command. And then if you want to have a color bar, which is often useful if you're trying to display data, you just use the color bar command. You can also do surface rendering in MATLAB. So you can get vertex points, which is basically all of these individual locations, these black dots. I don't know why my mouse is doing that. That's interesting. And then by saying which points are connected to each other, you can do a triangulation and get these 3D fields. You also can make videos. So this is also from my lab mate, Erica Mason, who does magnetic particle imaging. And by creating these quiver plots with time-varying fields, she was able to display how the voltage changes across time. I've made both GIFs and MP4s with MATLAB. GIFs are very stable in presentations and work almost everywhere. It's almost like a picture. Sometimes other videos you can have a harder time with presenting. If any of that code interests you, feel free to send me an email. But really, your imagination is the limit. All of these things were created using MATLAB. And so if you want to display a certain result, there's probably a way that you can do it with MATLAB. All right, so now I'm going to get into some more advanced topics, things that you can do in MATLAB. And I sort of touched on this before in my introduction, but there's really just a lot of different things that you can use MATLAB for. And this is an example of things that both Oppo and I have found useful in doing imaging research in particular, but it's by no means a comprehensive description. But just to sort of give you a taste of some of the more interesting things you can do. Okay, so the first thing I'm going to talk about is the parallel computing toolbox. So MATLAB loops can be slow. I didn't mention this before, but MATLAB is a high-level language. It's not known for its speed compared to something like C. And so you want to make it as fast as you can with whatever tools you have, since it's not inherently a fast language. And so the example here is that you want to do an intensive simulation for a grant, and it's due in 1 week. But the simulation takes 2 weeks because you have this single large for loop where you have to do lots of examples. And the thing is, for these for loops, though, they're independent. So what's going on for all of these different examples doesn't affect each other. So you don't need to do them sequentially. And so, sorry, I'll just talk about this for one more second. And this is a situation where you can use the parallel computing toolbox. You have to think about whatever individual problem or data analysis that you're doing. And if you stop and say, okay, are these independent? Yes, they are. Then you can probably go from a for loop to a parallel for loop. But this will use multiple MATLAB instances. So if you're on Linux and you want to see everything that's running and you type in the top command, you won't just see, oh, Haskell is using 1 MATLAB, it'll say I'm using 20 MATLABs. But it still only uses 1 toolbox license. But you also need to have the parallel computation toolbox at the center. I want to say we have 6 maybe. I could be thinking of a different toolbox that I use often. So you can't necessarily use it all the time, but there's normally one available. I pretty much only have an issue getting one if it's like right before a big abstract deadline or a conference deadline or something. So this is what the code itself looks like. So instead of having a for loop like I had in that example earlier, you just say par for parallel for loop. Before you can run it, you want to delete potential pre-existing pools. If you know you say have 20 cores you can use, but you already had a parallel pool running with only 10 cores, MATLAB will automatically use that one before. But if you know you want to say have 8 specifically, close the old one, start a new one using parpool, and then you'll have 8 different CPUs that can run what you're trying to do. And oftentimes it's helpful to do timing. In MATLAB, tick and talk are a good way to time things. So if you say tick, code runs, and then talk will return the elapsed time between the last tick. And so doing this parallel for loop, it's taking the eigenvalue decomposition of random matrices and putting them into this vector C, which was allocated using the zeros command. And then it'll show how long it took. And then when you're done, you can delete the pool object. And so if you want to play around with this, see what your MATLAB chops are like, this is sort of a fun example to play with. If you want to compare the elapsed time, if you simply just removed the par here, how long it would take with a for loop versus a parallel for loop. Okay, the next more advanced example I'm going to get into is calling MATLAB from Python, or calling Python from MATLAB. And it's actually very easy to do this because you use the system call. And the system call basically says, okay, don't run this in MATLAB, just run this from my Linux commands line, essentially. And so this is an example where I'm calling Python from MATLAB, but you can also use this to call different types of scripts in other languages and do other things on your machine. Okay, so this is an example based on my research. And I have a disclaimer at the end, but this I put together so that it would be easy to read, but it hasn't been debugged or tested. So if you see an error in it, I wouldn't be surprised if there's 1 or 2, but it has sort of all the like key components to running Python from MATLAB. So I've set this up where I have a function that I want to run. So the idea is that I would be doing some sort of computation in MATLAB, and then I have this image XN that I want to pass through a CNN, which is a convolutional neural network. It's a machine learning tool that can basically be trained to do lots of different things. And so I want to take this image and then I want to run it through the CNN, and then I want it to return the output from the CNN. So some of the inputs that you also need to give to your MATLAB function is the Python script path. So, you know, where is this Python script on my computer? It might be in your current directory, but it also could be somewhere else if you save them in a different part of your hard drive. And then also the scripts that you want to call. And so the first thing you'll do is you can just append the path to the file name using comma, the comma operator. So this will just take two strings and put them back to back. So if you had the string A and B, and then did A comma B, you would now have a string that says AB. And you also oftentimes want to have input. So in this particular example, this is the specific variable x in that I want to run through the Python script. So before I can call my Python script, I have to save this to some temporary MATLAB file so that Python can open it. And then once the Python script runs it, it needs to save the output. And so this is what I want my output file name to be called. Here I just use temp, but you could also have these file names be input to the MATLAB function itself. And this is what I want it to be called. And so then you can create this full string. This is the system command string where the first thing you want to say is Python, and then you have a space. And then you can put all the other information. So if you take this and then evaluate it, I have it down here. It's Python, and then say you have, this is just on, these paths are normally super long if you're actually on the cluster because you have your subspace and then your different places, but I just made them short for display here. You have the directory where it is, Python, and then .h5 is the CNN model name. Yeah, CNN file name. That is something I can edit these slides when I put them up. But so this would be a string that says my CNN, and that's the specific function I want to use, or the specific CNN I want to use to run it. And then it also has the input variable, the name that it is within the .mat file, what I want my output mat file to be saved as, and what the variable name is going to be. And so you can take this string, and then whether or not you do or you don't want the output printed to the command line, because sometimes within your Python script you could have something that said loaded data ... step 1 done ... If you do or don't want to see those in your MATLAB command line, you can just change the syntax here depending on what you want. And then you can load the output and return xCNN within this function. And so to show you what the sort of corresponding stuff would be in Python, if this would be your Python script called run_cnn.py, and it would be at this specific directory. The system command is key. That's the command that is used to run the script. And then this particular file name, if you look at this Python call, all of these strings can be parsed using the sys.argv command. And then you don't want the first input because that's actually just the name of the scripts that you're calling, but you want all of these strings afterwards because that's your input and output. And so here I've put the model name, and since that's the first thing that comes after my Python script, and I've taken away the first entry, it's going to be at the first element of this var vector. And one thing that you might notice here, this highlights a difference between Python and MATLAB, is that in Python, all the indexing starts at 0. So if you want the first element of a vector in MATLAB, you would say 1, but if you want it in Python, it would be 0. So here, our model file name is actually var 0, whereas if this were MATLAB, it would probably be var, and it would also be parentheses instead of brackets. So these are all just sort of little differences you pick up along the way. And then this would be the outputs. You load the input using the input-output command load mat. Then you can do whatever you want to do in your Python script, and then this is the syntax for saving it to a MATLAB file. And like I said before, this is a simplified code snippet. All of these functions are the helpful ones, but if you put this exact stuff into your editor, you may or may not have bugs. Okay, and so I mentioned that, so I went through that Python example in detail, but you can also run MATLAB scripts from the shell. So this is something that I know Oppo has done a lot in his research. So if you have a shell process and you're maybe using FSL or free surfer tools to look at different data, you can call MATLAB in the middle of the stuff that you're doing. And so as Shaheen talked about, you can use the MATLAB.new command if you want to use the newest version of MATLAB. And so that will start MATLAB sort of in the background if you say no desktop and no display. And then you just use the -r command and then run. And then this is the name of the MATLAB script that you will run. But in this instance, you don't use the .m extension. And if you think about before when I was running stuff on the command line in MATLAB, that's because if I had a script, I wouldn't say run script.m in MATLAB. So this is sort of what you would just write to the MATLAB command line. Then you also need to make sure that the last line of the file is exit so that you don't have this MATLAB job that's hanging. And so if you need to pass in variables, you can use the get_env environment or in the set_env environment to do this. So these are just some examples of the syntax for that. And then the opposite, doing Unix commands from MATLAB, it's very similar to the Python example I had before. So you can use the system command or you can use Unix. System is sort of like a broader high-level command, which will call Unix if you're on a Unix system, or there's another name for the function it calls on Windows and Mac. So I use system, but you can also use Unix for this purpose. And so here you have the command string like before where you want to run this command. These are the inputs. This is an option that you have. And then you just run the Unix command string. And if you get a 0 back, that means that there were no errors, but you should always check your results. Oftentimes I'll run things in Python, but I'll do all of my plotting and error checking in MATLAB. All right, any questions on running Python or Unix? In Unix, I would have to look at the MATLAB documentation for that, because I've used the system command with Python, but I haven't personally used the Unix command. But
command Unix.
It's command.
Just a Unix, and then you're doing a Unix command, and that's it.
Yeah. So
just Unix.
So there shouldn't be any output by default. Okay.
Oh, you can see the output, and you can get the output and use it. So.
Awesome. All right. Thank you, because I haven't used it before. Okay, so now sort of the last advanced topic I'm going to talk about, which is near and dear to my heart since I do a lot of optimization, is how you can set up a custom optimization in MATLAB. And to do this, I'm going to use a specific example of something that someone in my lab was trying to accomplish, and I helped set up a small script for her to do this. But these general principles can be used in lots of different applications. So say you have a bunch of capacitors that can be connected in series, and you want those to have a specific final capacitance. You have a desired capacitance, which is 6.95 microfarads, and looking around the lab, you don't have any capacitors of this value, but you have some of these values. And you know that your total capacitance will be the sum of the inverses of the capacitances of what you have scaled by the number that you have. So this particular equation isn't important, but let's just say this is the physical problem you're dealing with. This could really be any problem at all. And you want to figure out what scale values x1, x2 will give me the capacitance that I want. And so the way that you can do this is by setting up an optimization. And so this is a general equation for how you would do a minimization. And so what it's saying here is argmin is short for the input argument, x, minimize this whole value. So if x is my input argument, I want to change it to minimize this to find the optimal x. And so these, the sort of like two lines on the end, that represents the norm. So if you can customize this to have this value be whatever you want it to be. And so you have some desired capacitance, and then you subtract it by this function that takes X as an input, and then will give the total capacitance as an output. And you're just trying to minimize the difference between these two values. And so this, if you're reading through the documentation in MATLAB, you'll see it's called the objective function. And your objective function is what you're trying to minimize. You can think that the objective is to make this function as small as possible. You might also be trying to maximize something, in which case you just can put a negative value at the end of your objective function, and now you're minimizing it instead of maximizing it. But the general notation for most minimizers is to minimize, or optimizers is to minimize them, not maximize them, including some in MATLAB that are used routinely. And so we have this specific problem. We can write a custom objective function that will perform our objective. And so there are lots of different ways that you can do it, especially in MATLAB. Okay, and so this is where I sort of want to talk about going from these equations, where we sort of have math and modeling, but we want to convert them into actual code. So we take those equations and we can write an objective function, where here we are computing the total capacitance given X is a vector of how many of each of these things we have. Caps are the values of the different capacitors. And then C desired is what we would hope for the capacitance to be. And so the first step of this objective function is to just weight all of these capacitors by their values. And so this is essentially in code what this equation is saying. And then the subtraction here, finding the difference between what you actually calculated and what you want, is this line of code here. And ABS is short for absolute value. So you want to get as close as possible, but you don't care if your estimate is above or below. All right. And then when we eventually try and do this minimization, the first output, here you can see that there's two outputs. This value, C error, is what will be minimized. Okay, and so this is how you could set up a script to do this. At the top, we have set what we want the capacitance to be. These are the capacitors that we have in the lab. And then the numeral command is number of elements. So it's similar to size, except if you do size, it'll give you the number of rows and columns and in the third dimension. Numeral will basically just take account of all of them specifically, so it'll be like the product of if you called size. And so this will just give you the number of capacitors. And then depending on what type of optimization you have these different constraints. And so you're going to have different constraints for different optimizations. So here, this LB, this is for lower bounds. We can have 0 capacitors with 5, but we can't have -2 capacitors with 5. And then also upper bounds, this basically says that we can't have more than 10 of any of these. And then you also can set integer constraints, and this basically says that every single one of these values needs to be an integer. And all these different optimizations have different requirements, and this is an example where the high quality MATLAB documentation is very helpful. You can do different minimizers like fmin-unc, which is short for function minimize unconstrained, fmin-con, fmin-search. Those are 3 that I knew, but when I looked it up before this talk, there was a list of like 50 different ones you can use. So it's really good for this sort of custom optimization. The one that we're using here is called GA. It's short for genetic algorithm. If you're interested in more details, I'd be happy to talk about it. And the variable that we're minimizing, we denote by putting an @ symbol in front of, and then it's the first input to this function compute C, and then the output is going to be the variable. Basically, this value of X is going to give us the capacitance that we want. And then we can use this function again. Before we were minimizing it, and instead of having this be a variable, it's a specific value, XGA, put it in, and you can get the capacitance and then display your output. And so that was sort of a toy problem, but to show an example, we used the genetic algorithm in our group to actually do magnet design. So for this paper, where Clarissa Zimmerman-Cooley was the first author, we were working on trying to create a portable magnet, made only permanent magnets that was lightweight, but we needed it to have a specific field. And so if you just put a bunch of permanent magnets together and try and create a field, you're not going to get something very homogeneous. You're not going to have something that's good for imaging. So we had this specific custom magnet design that we got by basically adding a superposition of fields from different rings to each other, seeing which rings we wanted to have highly magnetic materials versus just spacers that had no magnetic materials. And then for the different inputs of where in our magnet design do we actually have magnets versus spacers, we can do this linear combination of fields to come up with a magnet design where we have a linear gradient in this direction and a more uniform gradient in this direction, which is what we were hoping for. Okay, and so I'll go through these really quickly now that it's been almost an hour. So we have a number of MATLAB licenses in various toolboxes, and there's a limit to them. The lm stat-a command is very helpful. It'll show you how many are checked out, by who, and when they checked it out. There's only 6 parallel computing toolboxes, and you saw that there's one person who has 5 of them since, you know, last Monday. You can maybe email help and say, is this person actually still using these? Or, because I think you're not supposed to have licenses out for more than 3 days. And then there are a lot of different MATLAB toolboxes for Nifty, for looking at Nifty files, FreeSurfer, different MEG and EEG source analysis packages. Athene has MATLAB toolboxes, and these are all things that are installed on the cluster. So if you go into the folders that have the public software folder, for example, you can see what packages are in there, and then you might not actually need to install any of these things. They might already be there. This is just about your startup file. If you know that you always need to use certain paths, you can change your startup file by just adding those paths. Okay. And then these are just more notes on paths that I'll go through quickly. I had that example where I was using add path, but you can also use this other command called genpath, which will add all of the folders and subfolders. And then Launchpad is a computing resource here at the Martinos Center. If you want to run a MATLAB job on Launchpad, they have lots of information on this online. But there's only 20 jobs for a given user, and only one job uses any toolbox. And you need to know that for different jobs, you have a different number of licenses. So just keeping all of these things in mind are good for whenever you're on Launchpad. Okay, if you want to do MATLAB at home, you need to have a MATLAB license on your computer. I think remote access is the best way to do it. I personally use this software called No Machine, which I highly recommend, especially if you maybe have a Windows machine here and Mac at home, and then you're sometimes on a Linux box. You can just set up one remote desktop, and this No Machine software is provided by partners, and then from any of those machines you can just launch No Machine, and then you have your one desktop that when you close it at work you can open it on a different computer at home. And then if you have a Windows specific machine, there's maybe like easier things to do, but I found this works really well. But if you really need MATLAB anytime, anywhere, especially for, say, like on an airplane, you don't have internet access and you can't have your license checked, then you probably need to purchase a standalone license. Okay, so I think 2 minutes left. Thank you for listening. If you have are there any questions, or if you want to just send feedback, this is my email. So yeah, that's MATLAB.